In this video for section 9.1, we're going to talk about how to actually conduct the hypothesis test. So first, we're going to determine a level of significance, which is going to be given to us in the problem. But the researcher chooses the level of significance based on the probability of making a type 1 error. If making a type 1 error would be very costly, then they would use a smaller value for alpha. So then they collect the data, and we are going to use Minitab to calculate the p-value and compare the calculated p-value to the value of alpha. This will tell us if we will reject or fail to reject the null hypothesis. We will reject the null hypothesis if the p-value is less than or equal to alpha. We will fail to reject the null hypothesis if the p-value is greater than alpha. And if the null hypothesis is rejected, this means that we have sufficient evidence to support the claim, or the sample data supports the alternative hypothesis. If the null hypothesis is not rejected, then this is not enough evidence to support the claim, and the sample data is supporting the null hypothesis. So this is the process. First, we state the claim and determine our null and alternative hypotheses. Then we will determine the significance level alpha and state the rejection rule. If the p-value is less than or equal to alpha, we will reject the null hypothesis. If the p-value is greater than alpha, then we will fail to reject the null hypothesis. So we're going to be using the same menus in Minitab that we use for confidence intervals. One sample z, one sample t, and one sample proportion. So we will determine which one that we're going to use. Obviously, we use one sample proportion for proportion problems. For mean problems, it depends on if our standard deviation is known or a population standard deviation, in which case we will use z, or if our standard deviation is not known, if we're using a sample standard deviation, then we will use t. So we're going to use Minitab to calculate the p-value. Then we will state our conclusion by comparing the p-value to alpha, determine if we will reject or fail to reject the null hypothesis, and then determine what this tells us about the situation. So, we're going to look at example 9.5. The parking manager for the Los Angeles Dodgers baseball team has studied the exit times for cars leaving the ballpark after a game and believes that recent changes to the traffic flow leaving the stadium have increased rather than decreased average exit times. So my claim is that the average exit time has increased. Prior to the changes, the mean exit time per vehicle was 36 minutes. So my claim is that the average exit time is greater than 36 minutes. The population standard deviation is equal to 11 minutes. So since it's population standard deviation, I'm going to use z. To test the parking manager's belief that the mean time now exceeds 36 minutes, a simple random sample of 200 vehicles is selected, and a sample mean of 36.8 minutes is calculated. Use an alpha level of 0.05 to conduct a hypothesis test. So my null and alternative hypotheses, my alternative hypothesis goes with the claim. So that's going to be that the mean is greater than 36 minutes. My null hypothesis will be opposite of that. So my null hypothesis is that the mean is less than or equal to 36 minutes. Since I'm using an alpha level of 0.05, I'm going to reject the null hypothesis if p, the p-value that I calculate, is less than or equal to 0.05. So now let's go to Minitab. We're going to go to one sample, and again we're going to be choosing from t, z, or proportion. In this case I have a population standard deviation, so I'm going to use z. I need to change this to summarize data and enter my sample size. sample mean, and the known standard deviation. Now this time I'm going to check the box that says perform hypothesis test. My hypothesized mean was 36. So whatever number that you think is greater than, less than, or not equal to in the alternative hypothesis, that number will go in this hypothesized mean box. Now I'm going to click on options. Now this time I need to change this alternative hypothesis box. I need to change it so that it matches the alternative hypothesis that I have written. So if I look at my alternative hypothesis, it's that the mean is greater than 36 minutes. So I'm going to change this to mean greater than hypothesized value. Then I click OK. And then down here are the results of my test. So sometimes the MyLab problems will ask you for the z-value. If that's the case, then you would enter the number that appears here. But the p-value is what I'm looking for in terms of the hypothesis test. So the p-value that has been calculated is 0.1519. So if that's my p-value, and if I compare that to the alpha of 0.05, this is not smaller than 0.05. It's larger. So that means that I do not reject the null hypothesis. And since I do not reject the null hypothesis, there is not enough evidence that the average parking time has changed.